Good morning, students.
Good morning, sir.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
Good morning.
Today we
Good
are
morning,
here.
sir.
Good morning.
Good morning. Today we are here to demonstrate two experiments to all of you. Myself and Mr.A.S.Khan are here to demonstrate two experiments. Number one is law of reflection, laws of reflection. That is your first one. And number two, determination of the time period of a simple pendulum. The first one, the law of reflection, how to verify, that I'm going to show you first today. And second one, Mr. Khan will show you how to determine the time period of a simple pendulum. Okay. First of all, you can see the board, green board. Here written here, aim of the experiment. So first you write down aim of the experiment. What is your aim of the experiment? That is
Excuse me, sir.
Yes.
Sir, we'll write this in a practical notebook now.
No, don't write now practical notebook. Write in notebook. We will send you the PDF. Then only you can write that time. Don't worry. Okay. So first thing, note down in your top copy or notebook, aim of the experiment, that is to verify the laws of reflection. Right. To verify the laws of reflection. To verify the law of reflection. How many laws of reflection who can say?
So there are
So
two
two.
laws of reflection. Two laws of reflection.
Two laws. What is the first law? Can you tell me?
Sir, the incident ray, the normal and the reflected ray lie on the same plane at the point of incidence.
That's the first law.
The angle of
The angle of
incidence
incidence equal to angle of reflection.
Angle of reflection.
Correct. First law is the angle of incidence is equal to angle of reflection. Second law is the incident ray, the reflected ray, normal at the point of incidence all lie in the same plane. So today I'm going to show you the first law. That one, that first law is what? That is your angle of incidence is equal to angle of reflection. Second law is already there because already lie in the same plane. We are doing on the same plane only. Incident ray, reflected ray, normal, all will lie in the same plane. That is already there. But the verification is the first law. Law in angle of incidence is equal to angle of reflection. That will verify. Now, after this M experiment, you have to write apparatus required. Right. Apparatus required. Okay. Apparatus required. What are the apparatus required? You must write down. The apparatus are number one, plane mirror, having a base stand. The mirror is mounted. See, the mirror is mounted on the wooden stand, which can place nicely on the plane board. That is a wooden plane mirror is already mounted on the wooden stand. You can see now. I can show you properly nearby. Can you see now clearly?
Yes.
See?
Yes, sir.
Yes, sir.
It is mounted. See now.
Yes, sir.
You can see easily.
Yes, sir.
This is your plane mirror. First one. Second one is your drawing pins or optical pins. Look at this. Optical pins. There are 4 optical pins I'm showing you. Can you see now? 4 optical pins?
Yes, sir.
Yes, sir.
So
Yes,
these
sir.
4 pins you have to take to verify. And then there are board pins or fixing pins. You can see very small pin, fixing pin over here. This one, fixing pin. This one, you can see very small pin. This one, this is fixing pin, board pin. So this way we can take this one. Then sheet of paper. then one sheet of paper over here, this bit paper, plain paper, foolscap paper, you take. Okay, then half meter rule. Half meter rule actually here I have not brought, it is in lab only. The half meter rule is there, sir. So half meter rule is there in our lab. Just a minute. There is a half meter rule. Here, look at this. This is half meter rule, not full meter, half meter rule. That means total length will be how much? Tell me. How many centimeter?
50 centimeter.
Who can
50
say?
centimeter.
50 centimeter, yes, half meter rule. Total is 100 centimeter, 1 meter rule, half meter 50 centimeter. This is needed, half meter rule. And actually ray box should be taken for this, but we don't have ray box here. We are using optical pin method. There are two methods. By ray box also can show, by optical method also can show. Now I'm showing you by optical pin method, not ray box, because you need a bulb, a box, everything is there. So these are the mainly apparatus required for demonstration of what? Reflection of light. So first of all, before we start our work, I can tell you one thing. Here, just I'll show you the diagram. Look. A mirror line, it is first placed on the horizontal line, which will be shaded here. The mirror. Then a ray will be drawn inclined to this mirror line. First of all. And two pins you have to put over here. One pin here, one pin here. And this is the mark end, which will be already the middle. You have to mark it. First you draw the line for which to represent the mirror line and mark the point end at the middle of the line. Then one inclined line you draw first. After drawing inclined line, two pins will be put over here. One pin over here, one pin over here. P and Q. Are you getting me, all of you? Diagram is visible or not?
Yes, sir.
Yes, sir.
Writings on the board are not clear. Yes.
Madam, can you spotlight to answer? Just a minute. Just if you can spotlight my answer, you can show. Or you can show my mobile. Can you see now? Spotlight. Okay. Madam?
Yes, sir.
Can
Sir,
I-
that's done. Khan, sir, can you just turn it little bit towards the right?
Right. Or you take my one, my mobile. Madam also on my mobile. Okay, it's coming. Okay. Now look at this. A line is first inclined line draw at this point. Okay. Then the image of this two pins, the two optical pins, object pin.
इसलिए मैं बोलता हूँ फोन यूज मत करो अभी हो गया ना
Hello?
सारा फोटो में
Listen to me, all of you. The image of these two pins will form over here. If I draw a line here, image of this one will go over here. Image of this one will go over here. Okay? So you can make it as Q dash and P dash. I can make it. This image you have to see through the mirror. You have to see from here only. Your eye will be fixed over here. Your eye will be fixed over here. You have to see the image of these two pins, the mirror over here. Two pins will be shown, will be seen over here. Image of these two pins. And see that image, you have to place another two pins over here. That is your R and S. After drawing these two pins, you have to join them. Okay? Tell me. Are you
Yes,
clear?
sir.
Yes, sir.
So when you join this is the ray which is reflecting back from the mirror. It is opaque surface. The ray is incident over here and reflecting back. Then at this normal point A, draw a normal. Draw a normal. by with the help of your what? Protractor. After drawing the normal, then measure this angle and measure this angle. So when you measure this angle, this is angle of incidence, and measure this angle, this is angle of reflection. So this angle should be equal to this angle. The angle of incidence should be equal to angle of reflection. If this angle is 20 degree, this one is 20 degree. 30 degree, 30 degree. So this one has to verify practically. That I showed you diagrammatically. Are you clear now, all of you?
Yes, sir.
Yes,
Now
sir.
I will show you
Yes,
practically.
Yes, sir.
How will you do that? Okay. Now let us fix up the board pins over here. I'm just fixing up. I've made it two folds, one fold. One side I'll make some angles, and another side also make another two, three angles. See now. Here, first I have to fix up the four corners. Okay. Then I have to draw the line first. First draw line longer than the length of the mirror. Little bit this side. I have to draw the line going the line. Can you see the board properly?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
First draw the line here. Here one side and here also one side. I'm drawing it to it at a time. So two lines are drawn over here. Look, because to save the time. Then you have to set it. Because why? This is the mirror line. I have to place the mirror on this line. Okay. And here also set it. At a time I'm drawing two lines. Then I'll show one by one. After that, I have to mark a point here in normal point. I have to make it here in. Okay. And here also mark it here 1 point in. Now, then one inclined line I'll draw with this horizontal line. A line will incline to this. You can draw a line. Incline. Okay. Let us first do one. Now look, this mirror I have to place it here on this line. I'm putting over here. Can you see now?
Yes, sir.
Yes, sir.
Now look. And two pins I'm going to put it over here. One pin is here, over here, and another pin here. There are two pins PQ, named it as PQ. Okay. Now image of these two pins will be seen this side. So can you just give me? Look at this image. Can you see the image?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
Yes, sir.
Yes.
Yes, sir.
Now image of these two pins. See, can you see through mirror?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Seeing the image of these two pins, I have to put another two pins this time. Here one and here one. By seeing the image. Okay. Now look. Closing one eye, I have to put it first of all. We can also see that straight side is for you. Just a minute. Make it straight first of all. So, now see here. I have to put it here. Now again, can you see now?
Yes,
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 sir.
sir.
Yes,
Look at
sir.
this now. The four pins lying in straight line. Look at this. The four pins lying in straight line or not? You know,
Yes, sir.
as you aim the
Yes,
bullseye, as you aim the bullseye in your shooting baliyatra, when you go to gun shooting stall and you aim the bullseye, that way you have to keep the eye over there, one behind the other, so that you can easily aim it and properly can see the 4 pins should lie in one straight line. The 4 pins should lie in one straight line. After that, you have to remove this. Okay? Let's go. Okay, now. Now, put it here. Please mute the audio. There. Pratyasha, tell me who's there. Pratyasha, keep the eye over there and tell me.
So someone with the name Good Morning.
Yes, sir. Somebody with the name Good Morning, he's playing again and again.
Yes, sir. Someone named Good Morning is playing the song.
Now see. I'm just joining now this point over here. See, the lines reflecting back over here. Okay, and the line over here, PQ, RS, PQ, 2 points over here, and here R and S, reflecting back from this point. Now from this point, I'll draw normal, so that you can verify easily. So when I draw normal over here, now it's a little bit point becomes a little larger. So anyway, little bit difference over there. Normal be drawn over here. Okay. So normal, can you see now? Okay. Normal drawn now. At this point, am I audible to all of you? Mic down. Hello?
Sir, I have muted them.
Okay, okay, all right. Now look, here the angle we measure it, it's coming 10, 20, 30, 40, or 40, 47. Okay. It's coming 47. 47 coming. Okay. This one, let's check it now. Yes, also 47 coming. This also coming 47. 47. Okay. So both the angles coming 47. This angle coming 47 degree. This angle also coming 47 degree. So when you measure this angle of incidence, it comes 47 degree. This angle also 47 degree. So both angles equal. Now it is verified. Yes or no? Tell me first of all. It is verified. Again, go for next one. If I will take another pin, another line over here, another line drawing over here, look, any inclined line, I put it over here. Okay, then 2 pins, I have to put it. One pin is here. Because my eye is not perfect, like Khan sir. My eye is a defective eye. Still also I'm trying my level best to see the 4 pins should line straight line. Anyway, now the image of these 2 pins will definitely show here through mirror. You can see. Then you can see the image of these 2 pins is visible through mirror this side. And that pins, I'm just showing you. Let me first contact the camera. Just remove the camera first of all. They're disturbing me to mirror. Camera just type disturbing me to mirror. Let me first contact. Then only I can. Your image is coming now. Okay. Now one pin I put it here. You can see. Then I'm putting another pin. Look. Exactly coming or not? See. So now I can see that. Yes, sir. Yes. Okay. Now look, two pins I put there only, and I've removed this one and encircle it. That is your R and S. And this one also put it here. Here. P and Q. Did you see that? All of you? That's okay. Now join this. So when you join this, you should carefully join this because little bit difference comes. Okay. This is your reflected ray. This is your incident ray. Now what we'll do, incident ray drawn, reflected ray drawn. We have to draw the normal at this point. Let's check normal. Now, see. Tell me, can you tell me, children, what angle comes over here? I know a little bit unmute them so that we can have an introduction. Children, tell me, the angle formed here 10, 20, 30, 40, 50. Look at this. 10, 20, 30,
Sir, nothing is visible
40,
clearly.
50. And here 10, 20, 30, 40, 50. That means what? What the angle now formed over here? Tell me. 50 degree. Normal draw here. This angle is, sorry, this angle is 50 degree and this angle also 50 degree. So both the angles are equal. Angle of incidence, angle of reflection. Okay. So like this, if we continue with other two, because there are 4 operations you have to do. If you continue that, you can have again on the same board, I can put another one. We can have 2 angles equal. Angle of incidence should be equal to angle of reflection. Now the law is verified. The law of reflection is verified by this optical pin method. I'm taking one more line. Look at this on the same diagram. Taking one more line. Suppose, okay, and I'm placing now here. Can you see that?
Yes, sir.
Okay. Now one more line I've taken over there, the same mirror, and putting two pins. Yeah. Now you have to see the 2 pins, how they lie in the same plane, you see. You're enjoying the music and also the practical class, no? That's why you need to have this music. See, another 2 pins you have to put by closing one eye. Because my eye is not perfect. Still, I'm trying my level best. Sir, please show that one. Coming down now. Left line. See now? Yes. Is it correct? Tell me. Tell me, is it correct or not? Tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
The coming straight line. Okay. Now, take out this and encircle the points here. And here take out also, encircle the points. Okay.
Disha, just
Now you
switch
have
on
to-
your video. Disha,
Yes.
switch on your video. There are 2 IDs. I'll remove one.
So here, now the line is coming this way. Okay. So you have to measure these 2 angles also again by your protractor. Let's see now how much coming. This coming 10, 20, 30, 40. 1, 2, 3, 4. 1, 2, 3, 4. 40. That means this is coming 40 degree. Which one? This one 40, 47. No? 47, 47. It is coming 40 degree. It is also coming 40 degree. Okay. And here also one more. We'll draw it. Let's show you. Line. We'll go over now. Again. Look. One line drawn. Place the mirror on the line exactly where stated, and now put 2 pins again. Can you understand?
Yes, sir.
Children?
Yes, sir. Yes, sir.
Okay. Again put another line inclined to the mirror, and you can have incident ray, and first of all you have to encircle it. Now, yes. Look at this now. You have to coincide properly all these 4 pins. Now you see. It is coming same line, all 4 pins, image pins and also 2 optical pins. Look at this. Through mirror. It is coming straight. It's coming or not, tell me.
Yes, sir.
Yes, sir.
Yes, sir.
The 4 pins should lie in the same straight line. Look. Okay. Because sometimes due to some errors, we may not get exactly. So here, 2 pins remove now. And encircle it. Remove the mirror. Now join this. So the point N and this one, you have to join it properly. This is your reflected ray. This is incident ray. Okay. Again, now measure this angle. We'll measure it. Second one. Second one, I'm going to measure it. Look. It is coming. I'm showing you exactly. 10, 20, 30. 10, 20, 30. 40, 39. 39. 10, 20, 30, 39. So here the angle varies. 39 degree here. This angle coming 39 degree. And this angle coming 39 degree. Okay. Now my work is over. The total experiment is over. I have to write down in the table. Now look at this. First one I draw. First one I drew this 47. Angle of incidence is 47 degree. How much was the angle of reflection I got? Tell me. 47 degree.
47 degree.
Yes, sir.
Second one I drew this. It is 50 degree. So first one was 50 degree and second one is
50 degree.
50 degree.
third one I drew this one 40 degree. 40 degree and this is also
40 degree.
40
degree.
And fourth one
39.
39 degree.
39 degree.
39 degree.
39 degree.
39 degree.
39 degree.
So angle of incidence and angle of reflection both are equal. Tell me sir. Very
Yes,
fine.
sir.
Sir.
That means your law is verified. Angle of incidence equal to angle of reflection. So here there is no graph. Only you have to complete the table and you have to stop there only because no graph over here. And now I think I will hand over this class to Mr. Khan to show you how to determine the time period of a simple pendulum because this is the total practical about the law of verification of reflection I showed you. That is over. Are you clear now? So
Yes, sir.
these
Yes.
numbers please note down. I have to
Yes,
also
sir.
note down this one. Please write down this one, all of you, because I have to send the PDF also to you. Please note down.
Yes,
this.
sir.
Yes, sir.
Tell me first one how much? 47.
47 degree.
47.
47 degree.
Next one, tell me.
50 degree.
degree.
Third one.
40 degree.
degree.
40 degree.
39.
39 degree.
39.
Now what is over?
39 degree.
Look, your look here. Just a minute. There are many in waiting list. Look, this is the graph. This is the table. I'll show you this
But
PDF.
it is not clearly visible.
Not visible.
Not visible, sir.
Not
Visible, yeah.
Yes, sir,
Can
sir.
you zoom your
Now
camera?
visible.
Not visible. So
Yes, and now is it visible?
Now it is visible clearly.
Okay. So this PDF I will show you. I'll send it to your personal group. Your group
Okay,
only
sir.
I'll send. Yeah.
Okay, sir.
Yes, sir.
Yes, sir.
Thank you, class. Thank you, children. Let me take out this.
Shut up.
sir.
Thank you, 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 children.
Thank you, sir.
Thank
So now Mr. Khan will come. Khan sir will come to show you how to determine the time period of a simple pendulum.
Khan Buddha.
Good morning, all of you.
Good morning,
Good morning, sir.
Good morning, sir.
Morning, sir.
Morning, sir.
Good morning, sir.
Children, just now you saw one experiment demonstrated by Mr. Rout that was about verification of the laws of reflection. Now, children, the next experiment which I am going to demonstrate you, that is how to determine the value of acceleration due to gravity at any place using a simple pendulum. Now, I have kept one simple pendulum. And this
So
simple
do you need
pendulum
the
will
children
help
to
us.
interact?
No, madam, not now.
Sir, kindly unmute yourself, Khan sir.
Okay, so children, this experiment is about to find the acceleration due to gravity at any place using the simple pendulum. So I'm
Priyanka, can you just switch on your video?
So I will come to experimental part after some time. So let me first write down on the board the things which you require, the theory, etc. Then I will conduct the experiment. So children, the aim of the experiment is to determine the value of acceleration due to gravity using a simple pendulum. That is G, which we usually write as symbol using a simple pendulum. And children, for this experiment, to conduct one pendulum, one pen, a piece of thread, etc. So let me write down the apparatus which you need. Now, apparatus required for this experiment, there are: number one, you need a simple pendulum. So simple pendulum means a ball suspended by a string. A ball suspended by a string. You need a stopwatch. You need a meter rule, meter scale you can say. A meter rule you need, and a clamp stand. A clamp stand and a cork stopper. A cork stopper. So these things we are going to use in this experiment. Actually, coming to the theory, I will clean this board. You take this note down. Write down these things quickly. Madam, I request you kindly spotlight the other device used by Mr. Rout. So these are the apparatus required. Simple pendulum, that means a box suspended by a string, a stopwatch, a meter rule, a clamp stand, and a cord stopper. Okay, so now let me clean the board. So
Khan sir, just read out. Khan sir, just read out what is written on the board because children can't see it clearly. Once again, just read out the content of the board.
Okay, ma'am.
So I think there's a network issue. If you can just. Yes.
Okay. Simple pendulum. Number one. Number two is a stopwatch. Number three, a meter rule. Number four, a clamp stand. And number five is a cord stopper. So I hope you are finished writing so that I can move on to the next part. Then comes the theory which is used in this experiment. Theory. Children, you know time period of a simple pendulum. T, capital T. It is the symbol used for that. It is 2 pi root over L by G. This is the expression on time period of a simple pendulum. So here L stands for effective length of the pendulum. Effective length of the pendulum. And G, you know, acceleration due to gravity. L is effective length of the pendulum, G is acceleration due to gravity. Now, children, if I square both the sides, it comes out to be T square equals to 4 pi square L upon G. Hence, G, this can now be expressed as 4 pi square L by T square. The same expression can also be written like this: 4 pi square divided by T square by L. 4 pi square L by T square is same as 4 pi square divided by T square by L. Children, this T square by L, if I can find out, I can get the value of G, because 4 is a number, pi is a number, you know its value, approximate value is 3.14. So 4 and pi, you substitute the values. If I can substitute what is the value of T square by L, G can be calculated. So how to find out this T square by L? For that, I have to conduct this experiment and I have to plot a graph between T square and L. The slope of that graph will be the value of T square by L. So T square by L, it is actually slope of T square versus L graph. That will be, generally we write it as delta T square by delta L. which is nothing other than this T square by L only. So if we can find out this quantity, then we will substitute. So the value of G will be 4 pi square divided by the slope of T square versus L graph. So this is the, sorry. So children, this is the working formula for this experiment. We are actually going to find out slope of T square versus L graph. So that if we can substitute here, the value of G can be found out. This is the theory. Please note down quickly. Children, is this visible to you? Yes.
So it's visible. So it's visible.
Yes, ma'am.
Children, you
Children,
can.
I think it's done. You have already written this. Children, you have written.
Rohit, if you want to say something, you can chat it.
This is a simple pendulum. This is the simple pendulum. If you make it to oscillate, the oscillations will be confined between two extreme ends. This is one extreme position of the pendulum. This is another extreme end of the pendulum. Children, the time this pendulum takes to go from this rest position, this is called rest position, this is extreme position, this is another extreme position. The time taken by the pendulum, the bob of the pendulum, to go from rest position to extreme position, then to come back, then to go other end, and again to come back to the rest position. This total time is called as time period of the pendulum. Or in other words, if the bob of the pendulum moves from one extreme end to other, and from there it returns to the previous extreme position, this total time is also known as time period. Children, we have to measure that one. So for that, what I am going to do, a tabulation we have to do. So it is now the tabulation. In the tabulation, what we will do? Number of observations. Effective length of the pendulum. Time for 20 oscillations. Time for 20 oscillations. Then time for one oscillation, which is also known as time period. That is T. And after you find T, in the last column, you have to find the square of T. So this will be the last column. Now what about the units? Effective length of pendulum we shall find out in centimeter. time for 20 oscillation will come in second. So that time period is also in second. But square of time period, its unit will be second square. So this is the tabulation. I am going to fill it up now. Number of observations we have to take: 1, 2, 3, 4, 5, 6. And I shall start with effective length of the pendulum to be as 100 centimeter. Then I will go on decreasing the effective length: 90, 80, 70, 60, 50.
Rout sir, can you come just next to Khan sir, because sidewise it's not coming clear the writing. Yes sir, if you can just stand in parallel to Khan sir.
Okay. So children, these are the different effective lengths for which we are going to find out the time period. First we shall start with 100 centimeter length, then 90 centimeter, 80, 70, 60, 50, 40. So total 7 observations we are going to take. So how to do so? Children, let's see. Now let me bring my apparatus in front of the camera. Children, this is the setup. You can see this is a clamp stand. Let me decrease the height, then only you will be able to see. Again, I will arrange it. Children, this is one clamp stand, and from that, this is one simple pendulum which I have suspended from by means of a clamp. This thread which you see, its length I have to adjust so that all these effective lengths can be taken. Now, children, can you tell me what is effective length of pendulum? Madam, can you please unmute them? Children, who can say what is effective length?
So the length of the box.
Effective length is the distance from the point of suspension to the center of gravity of the box.
Effective length is actually the distance between the point of suspension, from the point of suspension to the center of gravity of the bob. Look at here the diagram. This is the point of suspension. This is the center of gravity of the bob. From this point to this point, total length is called effective length. So this effective length now includes the length of the thread plus the length of the hook. There is one hook. Children, if you can see here, here one hook is there. And after that, there is a spherical ball. This is the bob of the pendulum. So hook is also there. So children, length of the hook and the radius of the bob, it is the radius length. This total length is called effective length. Now let me first find out what is this length of the hook and radius of the bob. Their sum total. Children, before this, I had already measured that one using this slide calipers or vernier calipers, and I found that length to be 2 centimeters. So I am not going to waste my time. This part, children, this length, the length of the hook and the radius of the bob, I have already measured. It have to be 2 centimeters. Before I started this experiment, I did that one. So what I am going to do, if I have to take a 100 centimeter effective length, I have to keep the length of the thread as 98 centimeter, so that the 2 centimeter, that is the length of the hook and radius of the bob, will be adjusted in. So remember children, every time, whenever I am going to take all these lengths, I will take 2 centimeter short. 100 centimeter means I will take 98 centimeter of the thread. 90 centimeter means I have to take 88 centimeter long thread. 80 centimeter means I have to take 78 centimeter long thread. This is how I have to do. So first reading I am going to take 100. So children, what should be the length of the thread?
98 centimeter.
98. Children, now I have got a long scale with me. This is a scale. and I'm going to measure 98 centimeter.
8 centimeter.
Children, here, children, this length is now 98 centimeter. From this point up to this point 98 plus 2 centimeter, it is adjusted. So total is now 100 centimeter. So this one I am going to fix there in the stand. So children, now what I am holding here in my hand is 100 centimeter long simple pendulum. So let me now suspend it.
So the bob is not visible.
Yes, just a minute. I had removed this one, that's why.
So still the bob is not visible.
Wait. That's it. Sir, can you just a minute? Set the camera so that you can see it properly. Children, I hope it is now
Yes, sir, now visible.
Yes, sir. Visible, sir.
Okay, let me go ahead, sir. Children, now can you see properly?
Yes, sir.
Actually, the bob is not visible. As I will reduce the length, after that the bob will be visible. Now it is going beyond the range, but anyway, no problem. Children, this bob will oscillate. And we have to record time for 20 oscillations. Because time for one oscillation will be too less. Very difficult to measure. So let us take time for 20 oscillations. Now children, oscillation means what? You will concentrate at one end. Suppose it moves from this end to this end, it is half oscillation. So one oscillation means it will come back. So it will go forward, then backward, back and to and fro motion. So once it will go forward, once it will come backward, that is counted as one oscillation. So like that, when 20 times it repeats, what is the time taken? I have to record. And for that, I am going to use one stopwatch. Stopwatch I am holding in my hand. So I have to record this time. And children, you can also do. If you have got any kind of watch with you, you just try to see how much time it is taking. But I think since it is going on live, error will be there. I will get the correct one. So children, I am going to start this. Stop the pulpit. Stop the pulpit. Stop the pulpit. I will hold it stopwatch. Some 12 meters stopwatch. Why right? I have to close that. You close it and make it flag mode. Let me leave the meeting. Make it flag mode. Let me leave the meeting. Till I am using my mobile phone to do this. That stopwatch is not working. Children, ready? So I am leaving it from here. So I have left it. Now 1, 2, like that it will oscillate. So I am going to start. When it will come to this end, I will start. I have started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So exactly 40 seconds it took. So children, when the length is 100 centimeter, the time for 20 oscillations came 40 seconds. So can you tell me what is the time taken for one oscillation?
2 seconds.
2 seconds.
2 seconds.
And time for one oscillation means time period. So time period is 2 seconds. Or I can write 2.0. So for 100 centimeter length, 40 seconds is taken for 20 oscillation. That means for one oscillation it is 2 seconds. So this is the time period now. Then what is the square of 2?
4.
So 4.00 I have written. 2.0 square is 4.00. Like that, now I have to do for 90 centimeter length. So I have to reduce the length now. So let us reduce the length. So let me remove this first. Now children, scale is here. So 90 centimeter means what is the length of thread I am going to take?
88 centimeters.
88, because 2 centimeter is already adjusted as the length of the hook and radius of the bob. So that 2 centimeter I have to exclude. So 88 centimeter length is here. So children, this length of the thread which you see, this length is 88 centimeter, rest 2 centimeter. So total comes out to be 90. So let me fix it there now. So this is now 90 centimeter effective length. Let me fix it. Children, now it is 90 centimeter taken. So once again, I am going to oscillate it and I will find out so children, I am going to give it oscillations. So it started oscillating. Do not start exactly from the beginning. Let it oscillate. Now, when it will come this end, I will start. Children, I am going to start. I have started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now children, it took 38.8 seconds. What I measure, it is coming 38.8. So children, can you tell me what is the time taken for one oscillation? Quickly divide it, tell me. Divided by 20.
One 1.94.
So 1.94 seconds.
1.94. Do the calculation immediately. Now children, find out the square. 1.94 square. Or it doesn't matter if you find out 1.9 square. It doesn't matter. 1.9 square. How much is
0.38.
3.61. 3.61. 3.61. 3.61. Now children, we will take 80 centimeter length. 80 means what is the length of the thread?
78.
78. So let's take 78 centimeter now. So this is the scale. 78 is here. Now this is 78 centimeter long threads. This is 78 plus 2 centimeters. So total comes out to be 80 centimeter. So let me fix it here. So this is now fixed. So it is now 80 centimeter long. And this is now rigidly fixed in the stand. So now ready?
Yes, sir.
Yes,
My watch
sir.
is also ready. Let me reset it. Okay. Now, once again, you have to find time for 20 oscillations. Now, children, I think the bob is visible to you.
Yes.
Yes, sir.
Previously, in the two readings, you could not see the bob. Now it is visible because the length is reduced. So let it oscillate 2-3 times, then we will start. Children, I am going to start. When it will come to left side, I will start. Yes, I have started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Children, I got 36.8. I got 36.8. Now, 20 divided by 20, tell me how much?
1.84.
1.84. 3.24. So, children, if you take the square, you can take 1.8 square. You can just ignore this point 0.4. 3.24. So, the square of time here is coming 3.24. Now, next thing will be for 70 centimeters. 70 centimeter means length of the thread
68 centimeters.
68. So let me remove it again. This is the scale. So I have to take 68 centimeters. 68 is here. So children, this length, here you see it is 68. So plus 2 centimeters, that is the length of the hook. So total makes it out 70 centimeters.
Namaskar, namaskar. Khan Puraskar.
So children, this total length, effective length is now 70 centimeters I have taken. So let me fix it again here, understand. Now children, it is fixed. So once again we will measure it. Ready children?
Yes, sir. Ready.
Yes, sir.
So I will give it oscillation. You just wait for 2-3 oscillations. After that you start counting.
Yes, sir.
Yes, sir.
I'm going to start now. Yes, I have started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Children, I got 34.2. 34.2.
1.71.
1.71. So you take 1.7 square. 2.89.
2.89 seconds.
2.8.
So children, this reading is completed. Now we come to 60 centimeter. 60 centimeter means length of the thread will now be
58.
The 58 centimeter.
58 centimeter we have to take. $58 is here. 0 mark is at this end. So children, this length which I am now holding in my hand, from here to here, it is 58 plus 2 centimeters, so total 60. So this is now rigidly fixed. Ready, children?
Yes, sir. Ready.
Yes, sir.
Yes, sir.
I have started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Children, I got 31.4.
Yes, sir.
31.4. I got it. So divided by 20 will give you time for one oscillation. That is time period. How much?
1.07.
57. 1.6. 1.6.
Yes, sir.
1.6. Children, 1.57. So you can take 1.6 square. 1.57 is nearly equal to 1.6. So 16 square 256. So 2.56. We can take 2.56. 1.57 is nearly 1.6. So 1.6 square is 2.56. Now come to 50 centimeter length. Now 50 means I have to take 48 centimeter. This is now 48 centimeter. So plus 2 centimeter makes it total 50. So this total is now 50 centimeter length I have taken. Let me bring it down. Children, I have taken 50 centimeter length effectively. Let's start. Oscillations given. Now I am going to start. Started, children. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Children, I got 29.
8.
29.0. Yes, 1 point.
So 1.45.
1.45.
1.45. Sure.
Yes, sir.
Now find the square.
2.25.
You can take 1.25 is nearly 1.5. So 15 square, 225. So it is 2.25. You can take here.
2.5.
Now the last observation for 40 centimeter length we said. What means 38 I have to take. So this much. Now children, this is 40 centimeter length I have taken. Yes, children. Children, I am starting.
Yes, sir.
I am starting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Children, I got 26.48 or 26.5. 26.5 I have got. Divide by 20.
13.25.
1.325.
1.325.
325.
32.
So 3.
Rout sir,
325.
can you take the camera closer to the board? Because
Yes, ma'am. Now it is not. Yes. There is one. Let me remove. Experiment is over. Children, experiment is over. Now only calculation left.
sir, kindly go to the other side of the table. It will become clear. It's coming haze. Khan sir, can you hold the camera? Yes, sir. Yes, sir. Thank you, sir.
Children, is this 1.32? 26.5 divided by 20? Find the square and get me how much coming.
1.69.
1.7. 1.708. Approximately. So children, this is the calculation complete. Now we have to plot a graph. This graph I am showing you. Sir will show the close-up. Sir will zoom the camera so that you can see how to plot the graph. This is something very important part of this experiment, the plotting of the graph. Now, children, before I plot the graph, you complete these calculations. And let me write here also in my record. So we started with 100, 90, 80, 40. Second. 30, 36.8, 34.2, 31.4, 29.0, 26.5. Then the time periods are 2.0, 1.94, 1.84, 1.71, 1.57, 1.45, and last one 1. T square 0, 3.1, 3.24, 2.89, 2.56, 2.25, 1.70. So this is the tabulation completed. Now let's see how to plot the graph. Children, the graph papers you will find at the back side of your practical record. And remember, the practical record which you will use, it will be a physics record. In the shop, you are practical record. How you will know it is a practical record? At the back side, you will find graph papers. If the graph papers are not there in the practical record,
Excuse
it
me,
is
sir,
not a
your
physics
voice is
record.
breaking.
Please be careful. So don't buy a botany record or geology record.
So your voice is not clear. So not the paper.
So children, I am saying that you will use a physics practical record. How you will know that it is a physics practical record? At the back side, you will find graph papers in that record. So that is a physics. Let's see how to plot.
Meter scale. Voice is clear now.
Select y-axis. You know generally when you plot graph, you draw x-axis and y-axis in the middle. You will take x-axis and y-axis at the extreme ends like this. This is how you will take the axis. So this is x-axis, and in x-axis we are going to take effective length L. So this is L in centimeter. And in y-axis, we are going to take the value of t square. So t square in which unit you can see second square. So t square in second square. This you have to take. Children, this is 0. I have to take up to 100. So let me do one thing. This is I am taking 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So let me mark like that. 0. This is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So these points are taken. Now in y-axis similarly, what you will do? Let me mark these points first. Children, each you take it to
Khan sir, you can
Your
alternate
voice
your
is
audio
cracking.
in another device.
So we can
So your
hardly hear you.
video is freezing and your voice is breaking. Kindly use the other device.
I left that meet, so if you can kindly.
So you are muted.
Sir, kindly unmute yourself.
Yes, ma'am. I think in this it is happening.
Rout
Ma'am,
sir,
it's
you
okay.
can switch off your speaker.
No, my speaker is okay. Actually, the other phone speaker we have switched off.
Yes, sir. Thank you, sir.
3.50, 3.75, and you can see our highest value is 4.00. So I hope you can see the graph paper now. How it looks like now.
No, sir, it's very easy.
Yes, sir.
No,
It's
So it's very easy. It is not
Yes,
clear.
it's not at all
very
clear.
easy to remember at all.
Children, you just zoom whichever camera looks clear to you.
We cannot.
Children, there are two devices. One I am holding, my name is there, and one Mr.Rout is holding. So whichever one you find clear to you, you can see in that. So children, first I'm going to start with the lowest one. Children, the lowest one is 40 centimeter length. In 40 centimeter, it is 1.70. So children, here it is 40.
Sir, in neither of the cameras it is visible.
It is 1.5. Now this is 1.75. So children, this is 1.5. Children, at 40 centimeter,
So your voice is.
here it is 1.50.
Your voice is breaking.
Your voice is not coming.
So the next one will be 1.55.
So your voice isn't
Then
coming clearly.
1.60, 1.65. This is 0.70. So children, this it will come. Children, 1.7 we are getting here at 40 centimeter length. Then the next one is at 50 centimeter, it is 2.25.
Shay, you are muted.
Khan sir. Khan sir, you are muted. Your camera has got disconnected. So the camera in which you are showing the graph, I think you can unmute it, but it has also got less network.
Sir, you are muted.
Khan sir, you are not audible. Kindly unmute your device.
Children, at 60 centimeter. So children, at 2.56, so I have taken 2.55. Phone's mic is on. Wait. Speak. What is disconnected? Okay, on. Okay, children, see. So at 60 centimeter, okay, I'm getting 2.55. Then at 70 centimeter length, it is 2.89. This is 70 centimeter, children. Now here it is 2.75. This is 3. In between that, it will come 2.87. So which is nearly equal to 2.89. So I can mark this point 2.75 and 3.0, the midpoint, that is 2.87. So I have taken it as 2.89. Then at 80 centimeter length, I have to take 3.24. You can see in the table. So at 80, 3.24 means I can take 3.25. They are very close. Now at 90 centimeter, I have to take 3.61. So children, here it is 3.5, 3.55, 3.60. I have to take 3.61. So it is the same thing. So this is 3.6, which is nearly equal to 3.61. And the last one at 100, it is 4. So children, all these points I have got in my graph paper. Now, I am supposed to get a straight line graph. But due to some experimental error, it may so happen that all the points may not come in the same straight line. As you can see, I am not getting all of them in one line. So you have to plot such a straight line in which maximum number of points are included. This kind of graph is called best fit line graph. So you try to fit maximum number of points in your graph, best fit line graph. So let me see which graph it is so. So children, I think if I draw this particular one, 5 points are coming in that. 1, 2, 3, 4, 5 points are included in that. So let me draw that one. So 2 points, they are just lying here and there slightly, so we can ignore them. So children, this is the graph completed. Now you have to find out the slope of this graph. So what we have plotted, it is a t square versus L graph we have plotted. And children, scale, what we have taken? In x-axis, as you can see, from here to here, 10 centimeter, 5 boxes, 5 divisions are taken as 10 centimeter. So children, what is the value of one division? Isn't it 2 centimeter?
Yes, sir.
Yes, sir.
5 divisions, I have taken 10 centimeter. So one division is 2 centimeter. Similarly, in y-axis, 5 divisions I have taken 0.25. So one division will be how much? 0.05 second square. Children, this is the scale I have taken. Now slope I will find out. How to find slope? On this graph paper, children, any 2 points of your choice you have to take. So let me take a point over here and let me take a point over here. 2 points of your choice. Now from both the points, you have to draw perpendicular. Or another method is also there. Children,
Yes, sir.
Yes,
you
sir.
have to draw one right angle triangle like this. The 2 points which we have selected, the distance between them, we will take the hypotenuse. And after that, you just draw perpendicular and base. You have to draw one right angle triangle. The length of the height and the length of the base, if you divide, it will give you the slope. The children, let us see what is this length of the base from this point to this point. Let me count how many divisions are included. 1, 2, 3, 4, 5, 6, 7, 8, 10, 18, 19, 20, 21, 22 divisions are taken. So children, 22 divisions will be how much? One division in x-axis is 2 centimeter. 22 division means 44 centimeter. So children, this length is 44, this one. Similarly, the height, how many divisions are there? 10, 20, 30 divisions are there.
30.
And children, 30 division means 0.75 because one division is 0.05. So 30 division in y-axis means 0.75 second square. So this is 0.75, this height. Now the slope we have to find out. Children, slope is equal to, this is, children, this is delta t square value because it is taken along t square axis. And this is delta L value. Slope is delta t square by delta L. So it is 0.75 divided by 44. Now this I can quickly calculate here. .75 divided by 44, it comes out to be 0.017. So nearly 0.02 you can say. So this is the value of slope. This value you have to substitute in the formula. Children, the formula, you know, what was the last formula you have written? You remember? It is 4 pi square divided by slope.
Slope of
Yes, sir.
t square versus L graph.
Of
Yes,
t
sir.
square versus L graph. So in that formula, you have to substitute. Now 4 into 3.14 square divided by the slope of value I have got how much? 0.02. So this you calculate, whatever value of G comes, you have to write down.
Yes, sir.
Let us calculate. Why to leave that one? So children, 4 into 3.14 into 3.14 is this divided by 0.02. So children, it is giving 1971.92.
Yes, sir.
This many centimeter per second square. If you convert this in meter per second square, it will be 19.7 meter per second square. So whatever value comes, you have to note down that one. So this is the value of G here in this place where I have calculated.
Very smooth test.
Okay, so children, this is the thing.
Yes,
this
sir.
is how you will complete this experiment. It is over. Now the reading, etc., all the things in the form of PDF, it will be sent to you. So that's all for today. 2 experiments we have demonstrated. PDF will be sent.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.